Good day, ladies and gentlemen. My name is Dev, and myself and my fellow colleagues Purvi, Adwitya, Sam, Rowan, Rebecca, Kathleen, and Faye have come from Sydney, Australia, Cumberland High School, to talk to you today about our research on how carpet can be turned into fertilizer. Now, let me give you some context. Interface Incorporated is a company that believes that businesses need to change their attitude towards climate change, and that by making themselves sustainable, other companies will follow suit. As their primary export is carpet, they were presented with this question: once it's been used, what can we do with the carpet instead of it going to landfill? As we were working with Interface at the time on a sustainability platform that helps schools around the world analyze their environmental footprint, in conjunction with the fact in Sydney the Department of Education throws out the carpet every 10 years and replaces it with new ones, we were able to aid them in answering this question as well. Now, as high school students, we're deeply concerned about the environment, alongside a global concern that action needs to be taken sooner rather than later. And with the help of Interface, we were given an opportunity to make an impact on this, and being able to conduct scientific research in a manner that is not commonly found in high schools. With this in mind, we got to work and started to learn what we needed to carry out our research, as well as being able to complete our experiment.
So to begin with, the plants chosen for the experiment were barley, canola, wheat, and spotted gum, and they were chosen because they are commonly used in large-scale farming contexts. They are commercially viable crops which can be profitable over time, creating real-world solutions. And to test these plants, we implemented the appropriate variables. The independent being obviously the ratio of wool fertilizer to soil, the dependent variable being the growth of the plants dependent on how much fertilizer was within them, and all other factors such as soil type, amount of water, exposure to climatic conditions remain controlled throughout the experiment. So to begin with, 27 students from Class 9 Red prepared the experiment by setting up 12 garden beds and planting seeds and sprouts within them each. So 3 beds were allocated to each plant type, 1 with 0% uncontrolled, 1 containing 10% ratio of wool fertilizer, and 1 containing 20%. Over the course of the following 2 months, we consistently obtained data each Monday and Thursday. During these sessions, the heights of the tallest and shortest plants were recorded. Each plant was measured slightly differently, however, the focus of them all was the heights of these plants. Across all varieties, the garden beds containing the 10% wool fertilizer ratio experienced the highest growth rate. We assumed that the 10% wood pulp was most effective, as we hypothesized that the 20% retained an excessive amount of moisture, which sort of overwhelmed the plant. This was especially observed in canola, as can be seen on the board. The 10% garden bed was the fastest growing and first to flower. It also had the largest number of flowers. In contrast, the 0% had no flowers and an average growth rate, and the 20% experienced the least efficient effects of fertilizer, as it resulted in significantly slower growth rate and lowest number of germinated plants. So the results are supported, as can be seen in the graph, that 10% is observed several times containing the tallest plant, and overall 10% grew by 32.5 centimeters, however 20% grew of a total of only 17.5. In wheat, the 10% container outgrew the others, with 20% containing the lowest amount of germinated plants and 0% containing no outstanding measurements. In 10%, the spotted gum produced the largest height and longest leaves, while 0% experienced a lower growth rate. In comparison, the 20% variety experienced a significantly decrease in health of plants. On the other hand, the barley reached the greatest height in 10%, however 20% was the fastest to mature, which adds to its commercial value.
Through the opportunity provided to us Cumberland High School students, we've acquired the skill on how to communicate our findings in an academic setting. With the strong encouragement and guidance provided by Interface, we as scientists, and more importantly, as high school students, have gained the ability to communicate and justify scientific findings to a corporate entity. With the resources supporting our research, we've been given the privilege of vocalizing our findings as we here are doing today. With the support of University Queensland of Technology, we've been able to shatter the boundaries and engage in professional academic research. With the aid of our partners, we're joining a scientific movement towards research in schools. During this experiment, we've been a party to hands-on experience. This is not a commonplace for high school setting. This includes being able to take soil samples and really getting our hands dirty by measuring the plants quantitatively and recording them qualitatively. We've also learned how to infer from other ecosystems observations of each other. Now, the biggest challenge we faced as a team was accurately measuring ever-growing plants. How do you grow something that measures so quickly? To tackle this obstacle, we decided to measure the plant at evenly spaced intervals. We had to collaboratively work towards a shared goal. From the data we collected, conclusions were formed utilizing trends that were observed in our graphs. These were that 10% produced the highest growth rate and 20% was the least effective. And as Purvi said, we thought the 20% kind of suffocated the plants. Now, this was the least effective ratio for plant growth, and this is going to drive future study. Now, through the interactions with corporate entities, we were able to stimulate the full potential of the project in a professional setting. This was imperative because it ensured a valid, reliable, and precise test that could be conducted to gather the most accurate results, as in the Greek term inteleki, meaning to reach one's full potential, which is exactly what we all wanted from this project. In conclusion, we as a team of scientists, and more importantly, as high school students, truly believe that change taking place in schools will change the face of science, and with generous partners such as Interface and QUT, the next scientific breakthrough is just around that corner. Thank you very much.
I'm very jealous of your school garden farm. I think brilliant. Never had a space like that in our school. So when you're doing the quantitative analysis, did you also look at sort of biomass of the plants, which is pretty difficult, I suppose, because you have to take them out of the ground and they're going to move it in your study, or do you look at the size of the roots or anything, or are you just measuring the height?
That was part of the further study. So we currently just wanted to see plant growth, seeing how it could really result in a product that visually we can see.
Yeah.
So biomass was something that Interface talked about being a further study point, but it was definitely there to talk about further study.
Because a lot of the guys in here are doing GCSEs, so it's one of the focuses is looking at biomass and energy, but I don't know what
No, that's a point of further discussion. That was really crucial to Interface.
you did a fantastic job as well. I really enjoyed listening to your talk. Thank you.
Right, Becky's got a question.
Yeah, I've got a quick question. Do you think there's any incentive for you lot to actually look at why you should chuck out these carpets every 10 years? Or is the company quite happy to redo all these carpets every 10 years, I imagine? Because I thought that would be quite an interesting project to look at the bacteria presumably they assume to be in the carpets, is why they've got to get rid of them. I just wonder whether you could turn it on their head or whether the company wouldn't like to support that. I just thought, it'd be a different angle to, you're trying to use up the carpet, but actually your research could say we don't need to chuck these out every 10 years. We certainly don't in English schools, do we?
We don't have wool carpets around here.
No, we don't have wool carpets. I just wondered what you thought.
Well, on that note, Interface actually has a patented design of carpet tiles. So they've actually fixed with sustainability as well. Instead of refurbishing the whole carpet, they use certain tiles and you can just lift them off. So specifically with Interface, what they do is they rip the then carpet off, which is considerably less than ripping a whole carpet out because you've only got half of the unit. And they use that latex layer on the bottom.